Hello guys, I am Rudraksh.
And I am Devesh.
We two are buddy for this task. So in this task, this is a sender code and this is the receiver code. We are sending the ultrasonic sensors data to the receiving end so that the LED will blink. When the distance is short, LED will blink as you can see. Now I will explain my code. First, we include the necessary libraries based on the type of Arduino board. These libraries enable us to work with Wi-Fi and MQTT. Next, we set up Wi-Fi credentials, the SSID and password for the network you want to connect to. Then I define two pins, trick pin and echo pin, which are used for connecting an ultrasonic distance sensor. I declare two variables, duration and distance, which will store the major data from the sensor. Moving on, we create instances of Wi-Fi client and MQTT client classes to handle the Wi-Fi and MQTT connections. We specify the MQTT broker's address as the port as 183 and topic as SIT210 waves for publishing data. We set an interval of 1 second for sending MQTT message and initialize previous millis to keep track of time. We also declared count variable to keep track of the number of loops. In the setup function, we begin serial communication at 9600 baud rate and wait for it to establish. We then attempt to connect to the specified Wi-Fi network using the provided credentials. We'll keep retrying until we successfully connect. When Wi-Fi is connected, we print a message confirming the connection. Next, we attempt to connect to the MQTT broker. If the connection fails, we print an error message and hang the program. In the loop function, we continuously poll the MQTT client to handle MQTT communication. We measure the distance using the ultrasonic sensor by sending and receiving ultrasonic pulses. We'll calculate the distance based on the time it takes for the pulse to return. If the measured distance is less than 12 units, we construct an MQTT message with the distance data. We publish this message to specify topic and introduce a short delay of 1 second before the next measurement. Finally, we increment the count variables to keep track of the number of loops. Now Lavesh will explain his code.
So we start by including the libraries of the Arduino MQTT client. Then these conditional include select the appropriate Wi-Fi library based on the Arduino based in use. Different boards require different Wi-Fi libraries, so we'll be using the libraries that I mentioned here. So then we will be filling the credentials of the Wi-Fi network we will be connecting to our Arduino Nano. Here the line specifies the pin connected to the LED or light, in this case pin 2. We create instances for the Wi-Fi client and MQTT client, which will be used for network communication. Next, we set up the MQTT broker configuration. Broker holds the broker address, port is the MQTT port, and topic defines the topic we want to subscribe to. In the setup function, we initialize serial communication and configure the pin for LED. We also connect to the specified Wi-Fi network and print status messages to the serial monitor. We establish a connection to the MQTT broker using the MQTT client instance. If the connection fails, the program stops. Once connected, we print a success message and subscribe to the specified MQTT topic. Then in the loop function, we continuously check for incoming MQTT messages. If a message is received, we print its details, content, and blink the connected LED. So we can see the messages that we will be getting here. So see, we can receive the successful messages. Thank you for watching.